So this is the new hacker's playground, right? We'll talk about traditional hacking and then web application hacking, the stages of an attack, the top 10 web application vulnerability threats and their countermeasures, and then a bunch of different tools for going against these. So this is the same diagram that we've been looking at, right, for a time here. They've labeled some parts of it. So we've got our web client. That would be our browser, right? Safari, IE, Chrome, etc. It sends an HTTP request either in the clear or over SSL. Goes over through a firewall usually. These days, most web servers are behind firewalls, but they let through port 80. We visualize that as this hole here, right? Traffic's coming through the hole. Goes to the web server. There may be server-side applications running on the web server and a back-end database. Now, sometimes the SQL database you see here is actually on the web server itself. Is that a good thing? No. So if you can break into the web server, then you can get to the database that's laid bare. So oftentimes the database is actually stored on another machine in a more secure location, let's say behind another firewall, to give it more isolation, right? And we've got these database connectors. So these web apps are connecting to the database in some method, and they're doing SQL queries. This could be through SQLnet or some other, protocol, right? It can be through ADO, ODBC. The web applications are written in a whole bunch of different languages, right? C, C++, C#, etc. Here's the web server, and it could be Apache, IIS, Netscape. It sends back an HTTP reply. So as a result of the application, on the server side, you're executing, getting data from the database, reformats, produces a dynamic HTML page or a page that includes scripting as well, right? And then that gets sent back to the user's browser, and it displays it. The magic of the web. Traditional hacking was not web-based, right? We targeted the operating system. We targeted the network programs other than the web server to see if we could log in through buffer overflows and other things, right? So we looked for attacks specific to the OS or the authentication. And that required that we be able to write buffer overflows in assembler language, write machine code, figure out the hex codes for them, put them on a sled with no ops, etc. Right? And then this is very complex, requires a lot of knowledge, requires the knowledge of a firewall protecting them, so you're not going to be able to get through to all those ports for these kinds of services, right? The Windows IPC dollar, Sun RPC, or the Woo FTPD. Instead, almost everything that's being presented is a web interface. So, where do the hackers go? Where the money is, right? Some people still do defacing websites. Usually that's your hacktivists. Other people are doing what? They're going for where the money is. Credit cards, they're exploiting it for profit. Even denial of service attacks are usually being done for profit, right? To keep somebody off the internet here. This is the OWASP Top 10 2010 edition. OWASP stands for what?
Open Web Application Security.
Yep. Profile. So every year they come out with their own top 10 Open Web Application Security Project. Right? They come out with their top 10, and they change slightly from year to year. The number one web application security problem is SQL injection, right? People trying SQL injection on fields, on forms. That's the number one way they get in. That's the number one way to bypass authentication, to grab items out of the database, etc. Number two, cross-site scripting. What's the major thing that people get with cross-site scripting? They steal people's cookies. When I was in kindergarten, my teacher wrote in the report card she sent to my mother that said, Mauro bullies the other kids into giving up their cookies. So I'm still doing that today. Getting them to give up their cookies, because what's in those cookies? Some of those cookies are session cookies. That's what we talked about. Remember we talked about if I can get somebody's session cookies, I can do what? I can be them. I can join their session. I can take over their session. I can get their basket of goodies. I can get access to their account. Maybe I can get access to their finances, credit card numbers, other account information, right? I want to get in their cookie. I also get to play their role. So if they're an administrator, have a special function. Other ways to attack session management, right? Through bypassing authentication or broken authentication. That also gets me into session management and session cookies as well. Goal is to become somebody else, take over their information, take over their accounts, etc. There's some other ones here. Insecure direct object references, cross-site request forgery. This is related to, but different from cross-site scripting. Security misconfiguration of the website. This means you're making parts of the file system available that shouldn't be, and other things. Failure to restrict URL access, once again, making parts of the website available that shouldn't be. Insecure cryptographic storage. You're not using keys properly. You're not encrypting properly. Insufficient transport layer protection, once again dealing with SSL problems, and then unvalidated HTTP redirects and forwarding right from websites. So today, it's all about risk management, right? So there's also an OWASP Top 10 risk rating methodology used to prioritize the top 10. These are just the changes from this year, from the last year. They've upgraded some of the risks, dropped some of the risks. Right, they removed malicious file execution just because that was a PHP flaw that's now dropping in prevalence. They've removed information leakage. It's no longer one of the top 10. And here you can see the difference between the 2007 and the 2010. Not going to go into their whole risk rating methodology and their weighting of the different examples here. But it's a fairly complex and thoughtful one, right? That's how they figured out that SQL injection got up to the top. Right? They looked at all the different weaknesses, all the different attacks, their prevalence, their technical impact. They're looking at criticality, impact, asset value, probability, and coming up with their top 10, right? What's SQL injection? We go through the web server and its application layer to get to what? The back-end database, right? If we get to the database, there's prizes there, there's all kinds of goodies, and there's possibly shell access, right? So how do we do that? Well, any kind of interpreter possibly can be susceptible to injection. SQL is just one kind of interpreter. SQL injection, I want to find out if my unvalidated, unsanitized input is just being passed to a database. I tried the little single quote command. If I can invoke a syntax error by just typing in a single quote on a form field, I know it's getting through, especially if I get a database spill, right, an error from it. I can also try to see if they're subjecting it right to the operating system shell, right? How would I go and see if somebody's subjecting something right to Unix or to, command.exe? Do a backquoted command. See if you can use a backquote on a field, and if you can get it exposed to the Bourne shell. You might also be able to get access to LDAP or other paths, etc. So it's very common in web applications. It's still out there today, even though there are good ways to avoid it and program around it and programs to make sure that you don't have this problem. The impact is severe. If it's there, it may allow access to the full database, to the schema to the database. It can allow read and write access, can allow deletion. And because there are stored procedures that allow shell access in Oracle and SQL Server, you can even break out of the database into the command line interpreter and pop yourself a reverse shell. Why did the database manufacturers put in a stored procedure and an internal library call to allow shell access? For convenience. There's reasons you want to write out information from your database, right? And then invoke a shell procedure to go take that new export file and FTP it somewhere or copy it somewhere, do some processing on it. So here's an illustration of SQL injection. This is fairly complicated over here, right? But what we've got here is a form on a field asking for an account number and an SKU, right? Application prevents the form to an attacker. Attacker sends data in the attack here. So what happened over here at the application layer, right? The user on their browser sent over something to the web server, right? An HTTP request. It's got this little bomb in it. It's kind of cute.